What we are performing here is what's called an AUC test, which stands for area under the curve. It is a common way we use to evaluate our bearings and comparing to each other. So we have an accelerometer there.
The spindle's at 80 psi.
Yes, so we are going to collect a power spectra analysis of the bearing while it's not rotating in the free state.
And then we're going to combine all the area under the curve, which is the AUC value, and that ends up right down there. So we'll start the test.
This will be conducted at 80 psi inlet pressure because that is the use case for this bearing.
And we're paying attention to this total AUC. Okay, so we have a total AUC of about 0.06. Now we'll turn the air pressure down to 70 psi, and you can see how much that changes our AUC value right here. And you can see there our total AUC at 70 psi is about 0.04. So now we'll run the pressure down to 60 psi, and you can see the AUC value will get better. AUC is a very fast way to measure air bearing to see how good it is. And it correlates roughly with asynchronous air motion, but not exactly.
Relative from spindle model within spindle models.
And so you can see we're at about 030. And my guess is if we went up above, if we go up above the rated pressure for this bearing, you'll see that we start seeing a little bit of an elevated AUC, but it would be a very small amount of asynchronous. So I'll run it up to 90 psi. And now you can do another test at 90. And you can see at 90 psi, we're getting a pretty elevated AUC value. So you wouldn't get the most perfect results if you were running the spindle at 90 psi instead of 80 psi. Ready to ship?